Hello, welcome to the SemiConscious. I'm Tim Weeks, and in the SemiConscious podcast, I talk to people who have interesting insights, who are making waves within the semiconductor industry, and who can provide us with really interesting and fascinating insights into the semiconductor industry and how semiconductors are marketed. So today I'm talking to Amir Sherman, who is a global business development consultant working with companies in the space of AI and particularly AI at the edge. So we're going to be talking to Amir about the issues that semiconductor companies face in trying to push this thing that is getting massive kind of hype globally, this concept of edge AI. So Amir, welcome to the show.
Hi, thank you. Thank you very much for having me.
It's our pleasure, and this is going to be really interesting because you've done work with in the past with companies like Edge Impulse. You're working today with Deepex and others, so you're right in the epicenter of this massive wave that is going through the electronics industry of AI, and particularly AI at the edge. So you've got some really interesting insights into how semiconductor companies really need to think about serving customers and making sure that edge AI can actually happen as opposed to just kind of promoting chips. So we're going to get onto that, but I wonder if you can sort of start off by explaining how you got to be, you're a business development consultant now. How did you get to this position and what brought you into this whole field of edge AI?
Oh, so this is a great question because all the time I love to share my long experience. So I started almost 25 years ago as a teacher in the army, teaching about microcontrollers. So was my job.
So this was in the Israeli army?
Correct. So this was in the Israeli army. I was teaching in a school and teaching microcontrollers back then. For the people with gray hair, it was 8051, 8086 assembler. And this is where binary was fascinating to me. I was finishing that journey and joined a company called Aero. Back then it was Aero Rapak. It was a subsidiary of the global Aero distributor. They just acquired the local distributor in Israel called Rapak.
So Arrow and Avnet, sort of the two biggest sort of distributors globally. So that was one of those, yeah.
Exactly. And I'm talking about 2001. And my job was to be the first microcontroller FAE at Aero Israel. This was my job. Back then, 8-bit was dominate microcontrollers in the market. 16-bit really started. And my first journey was with an unknown company that just changed the name from SGS Thomson to ST Microelectronics.
Right, okay.
This is where I started. And I was very successful in my early days, becoming an FAE manager very fast. And then, ARM started to roll on in the market with the first ARM7, later on Cortex. Aero got more and more franchise. Back then, it was Philips Semiconductor that became NXP, TI, Motorola Semiconductor that became Freescale, that later on acquired by NXP. And I was able to win multiple innovative companies in the Israeli market by really becoming super expert in microcontroller, 8-bit, 16-bit, 32-bit. I was really great at the embedded market back then, and won multiple companies that become monsters and giants in the market. Working for company was a startup company like Mobileye, that we all know where Mobileye is today, or a startup company called M System that been acquired by SanDisk, created the USB sticks, and many innovative technologies. Went up becoming a marketing manager, a business development manager at Aero. And my biggest change was in 2013 when the Aero president asked me to relocate to Germany and to manage ST Microelectronics for Aero in Europe. It was a big move. And this is where my mind moved from Israeli market to European market and later on a global market. And this journey was also successful. I was able to drive ST Microelectronics for Aero dramatically with several programs that I created. And again, one business manager of the year, being promoted to embedded manager of Aero, having in the end 52 engineers working for me in the European market, building what the Aero had back then called engineering service center, building AI. Back then, it was the beginning of AI strategy, 2018. Aero got the Nvidia line, the Qualcomm line, helping to develop community board like Dragon Board, and I was really into the embedded market. COVID happened, a lot of things changed. From a personal reason, I needed to come back to Israel after 6 years successful in Germany. And Aero asked me to support Israel and become the general manager of Aero Israel. But for me, it was like going backwards. I was really in a position of conquer the world, and now I needed to go back. So I decided that I was almost 20 years in the company and leave the company. And back then, I was so glimpsed, 2019, 2020, that Edge AI, back then it was TinyML, Edge AI, a lot of buzzwords in the market. Nvidia was pushing the Jetson, and I knew that something is going to happen in this market, in this space. So I decided to leave and open my own business consultancy company, because as you can imagine, 20 years at Aero, I got a lot of requests from semiconductor company to work for them. And I said, no, 20 years in a big corporate, I want to support small, medium startup. I want to support semiconductors, but as a consultant. And I started to win. I win businesses. Several semiconductor companies that still in stealth mode with me asked me to join forces, help them design and architect the SOCs that will come, help them to build eco partners, ecosystem, helping win system on modules and SBCs globally, community boards. And in the same time, I started to win
So just to say, Amir, so you're offering quite broad-based kind of support and advice there. So from product marketing through to kind of actual business development and sales.
Correct. So it was really, to help these companies to design system, understand exactly what the market need. But in the same time, I was hearing more and more, and I was into this AGI TinyML market. And I had, sometime in life you need luck. And I've been approached by a small startup called Edge Impulse that was just founded in 2019. And in 2021, they asked me to join as their global business development, semiconductors, and ecosystem. Exactly what I'm doing for other companies. And this journey was amazing. Okay, Edge Impulse back then was a no-name, and we had a clear goal to become the de facto a machine learning platform that simplify machine learning to embedded engineer. And as you can imagine, everything that related to TinyML, EdgeML, endpoint ML was really a part of my role. We were able to win a lot of semiconductors integration, and we were able to win eco partners and win enterprises, and everything was growing and growing and growing. And literally 4 months ago, Edge Impulse been acquired by Qualcomm, meaning that we did a good job.
Which exactly, that is, I think, a fantastic mark of success, isn't it? I think it became a very valuable company, and Qualcomm does not make those decisions lightly. So yeah,
exactly. And this was really the highlight of my role at the company, where a semiconductor company acquired us, meaning that they saw the value of what we have been developed, and the team, the embedded team there, the ML team, the engineering team, the sales team, everybody was working hard to get this, and for sure the founders, Zach and Jan. When this happens, I had the feeling that this journey is over for me. Again, I will not move to another corporate, so I decided to leave. And I joined another innovative startup company from Korea named Deepex. Deepex are developing their own neural processing unit, and they have AI accelerators in multiple form factors, going back to semiconductors and ecosystems.
Sorry, Amir. So with Edge Impulse, you're more on the software side. Deepex, you're going over to the semiconductor, the hardware side.
Exactly. But Tim, we talked several times. There is no hardware without software. There is no software that the hardware is not connected to it. So everything is connected. And this is what I'm doing now. My main focus is to drive Deepex sales and business development in EMEA and global business development. But I'm working for many other small, medium, big companies. Most of them are in stealth mode, support them. Everything is connected, because what I did, I created layer where different type of companies, neither you are a big semiconductor, billion-dollar semiconductor company, or you are a SOM or SI system integrator, or you are enterprise, you can approach me and I can help you. Because you have the SOC layer which is the best SOC should I choose to my coming application? And this is 25 years of experience. And if this SOC is complex, maybe a system and model can help you to get it fast to the market, because we know how complex it is today. And then the upper layer is, I need AI. Should I use the AI inside the SOC or external AI accelerator? And this is where Deepak is coming. And what type of software platform I should use for AI enabled? What is my operation system I should use? And I'm working for various companies to support all of that. And it's been a very successful journey for me.
Wonderful. Okay, very good. Well, thank you, Amir, for explaining sort of that and your journey to where you are now. So, I mean, what's interesting that you've got this experience sort of going back many years into the embedded devices world from microcontrollers and so on, and then but seeing how that's evolving as sort of the use cases change and the technology capabilities change with the advance in AI. So you've got a really interesting perspective on this. I wonder if, you've mentioned Deepak, a really interesting kind of AI accelerator startup who are doing very interesting things. But I wonder if you can sort of reflect on the challenge more widely for semiconductor companies. I mean, you talked about ST Microelectronics, which also you have a real kind of long history with. But many others. So, I mean, anyone in the microcontroller world that you choose to think of, so Infineon and Renesas and Microchip and so on, all of these companies recognize that there's a huge and growing demand for the capability to implement AI inferencing at the edge in small devices where there are huge constraints on memory and on power consumption and so on. So you're hearing so much in the market about companies coming out with edge AI microcontrollers or edge AI chips where they've kind of put some sort of AI acceleration hardware on their microcontroller somehow, and then saying, well, this is edge AI. I wonder if you can sort of explain to us, is that approach kind of working in the market? Does it meet customers' needs truly?
Yeah, so first of all, let's understand the market. Everybody can call it in a different way, but you can say that there is the microcontroller, super low power, battery operated type of AI market, and you have the mid to high end edge AI, microprocessor, AI accelerators, up to GPU type market. You can split that. Yeah. And people can call it tiny ML for microcontrollers, edge ML for processor, or you can call it in different type of ways. Now, it's also reflect on the capabilities of the AI. In the microcontroller space, we are talking about GOPS, okay, giga operation per seconds. Yeah. And in the microprocessor market or AI accelerator market, we are talking about TOPS, okay, the tera operation per second. Now, one thing that is super interesting in this market, most of the customers don't really know what they want. This is first. And if they know what they want, it's also depend on which division you are talking to customers. Are you talking to the ML guys where as a typical software guy, he need 10 gigabyte of RAM in his microcontroller because RAM is what he need, even though it's impossible, we know. And the ML guys say that I need 200 TOPS because I still don't know how my AI model will look like. And the hardware guys want that it will be super small and battery operated. And by the way, the management want that it will cost $5. So there is different type of angles about typical enterprise application. Now, also we need to understand the AI market is split to vision AI, everything regarding cameras, and depend how many cameras that you want. Voice or sound, keyword spotting, voice activation detection, everything that is regarding the sound. Or you have typical sensing, okay? You get a sensor, a CO2 sensor, a gyro, accelerator, anything that you need to drive type of IoT sensing data and you want to do edge AI to it. So it's really reflect different type of application. Now, there are so many applications in the market. Everything what's been developed in the past 15, 20 years under IoT is becoming AIoT. So AI into the IoT space. And neither the AI will solve your problem or AI will help you to grow your business, but it will do good for sure. And this is the multiple type of customers that I'm getting every day. Now, for vision application, a camera can be a big camera that you can see in smart cities that are connected to PoE with LAN, and power is not the most important thing. Or a camera can be something this small that can open a lock or be in your, open a door and do something very simple. In the end, it's an edge AI here and it's an edge AI there, doing face recognition or object detection or classification, any type of AI model. Now, for sure, if you're talking about an application that drive a low-end AI in one simple model, and you have a price constraints and a size constraint and a power constraints, you will think that in the end, microcontroller will not be able to do the job. And this is where you are wrong, because what happened in the last 3 to 5 years, ARM with their latest cores, starting from Cortex M55, moving to Cortex M85, and the new neural processing unit that they developed, like the Ethos U55, Ethos U65, and even the Ethos 85, or different IP companies like Siva, like Cadence, like Synoptics, they develop a lot of neural processing units that are able to run on microcontrollers, and some of it already now in production in microcontrollers. You mentioned ST Microelectronics. ST with the latest super cool announcement, the STM32N6, they developed their own ground-up neural accelerator that able to run at 600 GOPS, and they connected to a Cortex M80 and M55 that run at 800 megahertz. And think about these two cores. You have an M55 and a 600 GOPS neural network that they created to support low power application. Now, Renesas went to a different way where they were first utilizing M85 into the market and utilizing the helium DSP inside the ARM. Infineon choose an M55 with U55. Alif, a startup from US, have a double M55 and double U55 in different type of clocking. So, and there are more, you have more companies that are coming into the market with different type of acceleration to support that exact market. GOPS, low power, low cost, microcontroller, with or without small memories, and able to quantize simple type of model to support that market.
Yeah. So can I ask you, Amir, does this create a problem for the microcontroller companies in that kind of, if we kind of roll the clock back 5 years, let's say, when AI wasn't a thing for microcontrollers, and really it was all about embedded real-time deterministic control, and there they were, it seems to me as though marketing their products to design engineers was relatively simple, because the design engineer had a sense of, well, is my application kind of a Cortex M0 Plus type application, or is it sort of a Cortex M4 type, or is it kind of actually, do I need a high end and am I going to need a Cortex M7? And more or less kind of the market was split into sort of high end, mid range, low end, and customers, design engineers, understood that. So they could navigate their way through the portfolios of companies, of microcontroller companies like ST and Infineon and Renesas. And now that kind of common understanding has gone away, because with AI, as you say, you were just describing the multitude of different ways in which these microcontroller companies kind of are actually kind of implementing AI. And then it's not so simple, and you can't just necessarily just look at, as you say, is 500 GOPS enough? Is 800 GOPS enough? Is 200? It's not quite as simple as that. So it's become harder for the design engineer, hasn't it, to work their way through these portfolios of products?
Okay, so this is a complex question, and I will try to make it as simple as possible. First of all, not all applications today will need edge AI or TinyML. Okay, general purpose microcontrollers that need to transmit sensing data to via Bluetooth or Wi-Fi or 4G or 5G will continue. This is one. The second thing is that the market is still going to use low-end core for simple applications like Cortex M0 Plus, M23 or M33. And if you need bigger megahertz, bigger core, more memories, you will normally go to M4, M7, M33. But I believe sooner or later it will change to the new cores. Okay, so ARM will continue to drive this forward, and a general purpose M55, M85 running at 1 gigahertz will be a commodity. This is one type of the market. Another thing that we need to understand, AI is not new. It just changed the name in a different matter, meaning AI is mathematical algorithms. Mathematical algorithm can be driven by DSP. DSP is well known in the market and been used for many years. In the past, you needed to have a microcontroller and a dedicated DSP, mainly from companies like TI and analog device. With the latest ARM core, the DSP infrastructures and instruction went inside the core, and you have DSP instruction inside the microcontroller to run floating point application. So this will continue to be general into the market. Now, as I mentioned, AI is coming neither to solve a problem or neither to drive growth, okay? If I'm building a remote control, I don't really think for now what type of AI application, okay? You have an acceleration, you can do X, Y, Z, you can do, but the AI will not fix it. A microcontroller with RF and normally one SOC solution will solve the problem. What is changing is, first of all, the ability of semiconductors to add multiple cores in their design. So you see today a dual core Cortex-M is becoming commoditized, and M0 and M33, a dual M33, and you see it all around the world. Now, as the market will grow and learn, Edge AI will become more clear how it can solve a problem or help you get insight to different type of markets. And the semiconductor companies have this adding on to their portfolio. So ST, starting from the STM32 family up to the high end and finishing with an STM32 and 6, and there is going to be a family, and I'm still under the microcontroller environment. NXPs with their, IMX RT family and the general purpose families and the latest MCX families, and its various of application with inside memory or external memory. Infineon with all of their PSOC 6 and 63, 64, and now PSOC Edge with AI. So it's an add-on to their application, and you have it from Renesas and all of the other semiconductor companies. Now, what will happen in 5 years or 10 years? I'm not a prophet, but I believe that more and more Edge AI will go into a different type of application because you need to teach different type of market. You have a hardware engineer that normally need to look on how many and which are the peripherals you need, USB, Ethernet, PWMs, I2C, UART, etc., memories. You have the software guy that now get a request to add AI, so you need to understand the general core that will manage his own application, plus the core that will drive the Edge AI type of application. And again, you see microcontroller today with MIPI CSI. It's like impossible 5 to 10 years ago to connect a simple camera, or MIPI DSI to have a big display in a microcontroller form factor that will cost you $5 to $10. And this is one different type of market. So I see this as an add-on, and if, using my 25 experience, it will continue. So you will have a general purpose M55, M85, 1 gigahertz microcontroller, and the same one with AI acceleration. Neither you build it by yourself, or neither you're using ARM-based ethos or different type of IPs. And this will support the microcontroller market. Now again, 5 to 10 years ago, a 500 megahertz, 800 megahertz microcontroller will sound like science fiction. Now you can literally buy it online and start to play with that. And talk about adding USBs and gigabit Ethernet to a microcontroller. And this will create huge amount of opportunities for various applications and markets. This is one market. There is another market where this market was already being established by big players in the past 20 years. Intel, x86 boxes with cameras that was all around the market. And this started to change in the last couple of years with super cool SOCs coming from Qualcomm, companies like MediaTek and Rockchip that started from the consumer mobile market into the industrial market. And we all see today that you have a computer that is not running on Intel, it can run on ARM base. Same did reflect to the industrial market. And this opened, a lot of opportunities because it can be, I cannot say really battery operated, but low power and small. And if it's small, you can do multiple things with that. And it can go to aerospace and defense, to industrial, to consumer, to medical, having, application that in the past was like big big meters on meter can go small. And we see it in medical application and many types of application. Now, on top of that market that was dominated by these players, now you're adding AI. And then you are able to run TOPS type of application inside your socks. And what we saw in the past 3 to 4 years, companies, as I mentioned, like MediaTek and Rockchip and TI and NXP and Renesas started to come with quad-core Cortex-A whatever, 53, 55, 70s, and 1, 2, 4, 8 TOPS type of AI accelerator NPUs inside, because they knew that it's enough to run very complex AI model to your application connected to 1 or 2 or 4 cameras. In the past 1 to 3 years, and this is under my Edge Impulse hat, we saw this big wave of companies playing with Nvidia, because Nvidia gave them the opportunity to get whatever they want. A box that can run 20, 30, 50 TOPS, the Linux is booting, multiple cameras, and there is infinite opportunities. And they love it, and they created AI models, and they use Edge Impulse tool or different popular platform like PyTorch and Keras and Onyx model, and created and put multiple AI models to it. But then, when they understand that to take that box or take that SOM, because Nvidia is not selling chips, they're selling SOMs, the problem started that, okay, it's a GPU base, meaning that the power will be super big, the power dissipation, you need heat sinks. It's big, okay? It's not small, and it's costly. And then there was a question coming to me at Edge Impulse, and it's been a question all around the world. Do you have something that can replace my NVIDIA? Okay, I have everything working, but I cannot pay, or I need it to be smaller. And this is what we see now, a wave of a new SOCs coming. Qualcomm with their Dragonwing families, and MediaTek with the Genio families, and NXP with the latest IMX 9 families, and Renesas with the latest RZV family, and I can go on and on and on. And this type of SOCs are able to drive more TOPS, more connectivity. Now you're talking about USB 3, you're talking about not even gig, 1 gig, 2 gigs of Ethernet, 10 gigs, you have multiple encoder decoders, and this type of processors are now driving into the market. And it's opening huge opportunities. And then you need a software platform to move from the NVIDIA to others, and there is multiple opportunities in this space.
Absolutely, and it's really not surprising that these big chip companies have taken a look at Nvidia and the huge success of Nvidia and look, well, we fancy a little bit of that. So, of course, not at all surprising there. But I think part of the enormous success of Nvidia is not just that they produce fantastic chips, but that they provide a complete ecosystem that enables people to create the AI software as well as just providing a hardware platform. So very, very, Nvidia is famously has succeeded with that. To what extent is it going to be necessary for these other companies who are challenging Nvidia, so as you mentioned, or Renesas, NXP and so on, to what extent are they going to need to try to replicate, to match Nvidia in terms of providing that complete system solution, rather than just, I say just, it's a big deal, but just provide the semiconductor hardware platform for running this sophisticated AI?
Tim, this is literally the $1 million question. Okay, Nvidia, some people can debate is Nvidia is a hardware company or a software company. I personally see them as a software company, the best software company in the world, because they created the best CUDA infrastructure to support both edge, but mainly the cloud. And all of this Gen AI running on their servers, and they're doing massively great work, and they continue to grow. Now, coming back to the $1 million question, I think that if I will take 1 cent or 1 penny out of a question coming from any type of company saying, hi Amir, do you have a software that I can click of a button and everything what I did on NVIDIA can run on different type of solution, I will be rich. And we all know that it's impossible. And this is why semiconductor companies will raise or fall without ecosystem of their software capabilities, SDK, and simplification. This is why you see still, like mushrooms in the winter, new software companies popping up to simplify quantized AI model, taking data to deployment, exactly the story that Edge Impulse did and their competitors in a different ways. And it's super complex in the backend because you're talking about moving from GPUs to dedicated niche ground up NPUs that each company did. There is not a one. And again, DeepX is one company, but you have other successful AI accelerators like Halo and Blaze and MemoryX and Accelera. You have different type of SOCs with different type of NPUs, and it's super complex. The good news, it's possible. It's all about your level of engineering inside the companies and ecosystem that you're working all around, from the Linux side to the SDKs, to the drivers, to the AI modeling quantization, to working and supporting all of these popular frameworks and platforms that I mentioned. But again, it will not be easy. The time will be shortened and shortened, and this is why there is a new wave of software engineers that are becoming massively great with Python. There is many tools to support that, and this is going to be the main focus of the market in the coming couple of years. Let's be still honest. Nvidia was not focusing on edge AI. Okay, Nvidia 90 or 95% of the business is on the cloud, and they will continue to do it because what they care of, one, to dominate the Gen AI market, two, to have the global training of all AI model from now to the moon in their clouds. And by the way, it's a $100 billion of market that they can grow. The edge AI, where we are talking about less than $100 boxes, it's not Nvidia market. They don't want to play with that. It's normal. And this is where the big players like the SOCs and the AI accelerator will win. Now, there is one thing that I'm now doing with my consultancy is not everybody needs a SOC with AI, because his marketing message coming from internal is we are still not seeing it. Let's take a retail application or an HMI application. So they are going into the market and checking, and today the edge AI market for that specific segment is like 20%. So what? I will create an AI solution, but only use 20% of it, so it will be costly and I will not win. And this is why, again, super important question coming to the market. What should I choose? Should I choose a general purpose microprocessor without AI capabilities and add AI accelerator on top in the side? And then when I need it, I can add it because it's an M.2 type of modules, or you can have, different type of form factor developments and use it only when you need. Or maybe I design now with the best AI and it will be super expensive, but I will conquer the world. And there is no one answer. It depends on the application, on the market, on your abilities to drive into the market, to simplify the AI models that is needed to the customers. And by the way, this is why I need consultants. So this is how I make the living, and I'm here to support the market. But
well,
again,
there we are.
complex topic.
Absolutely. And people can get a flavour of that consultancy here by listening to you today. But so you talked about this software infrastructure that's required that Nvidia has been so good at, that there's a lot of development, many companies springing up to provide parts of the solution. Do you see any prospect that this might be somehow over time become standardized? I'm sort of thinking here of the analogy of in the mobile phone world, you've got Apple, which is kind of this huge proprietary kind of siloed system that is very successful in its own right, a bit like the Nvidia system. And then alongside it, you've got the Android system, which is kind of open and available to everyone apart from Apple. And that sort of standardization really works for all of the other mobile phone companies, mobile phone manufacturers who are not Apple. Can you see sort of something similar happening in edge AI, where you get sort of some sort of standardized software infrastructure?
So again, using my long experience in the last 25 years and checking what went to become standardized, what was not. I remember a long time ago where I had a discussion, debate with a Motorola semiconductor senior manager, where back then they used different type of cores. They have their own Motorola cores, and back then it was MIPS cores, and ARM started, and people said that there's going to be varieties of cores in the market, and we all know that what happened to some of the cores, but now we know you see RISC-V is coming and you see different type of cores. From a hardware side, I will say that there is going to be a 2, 3, 4 common cores to support the AGI market, neither connected to different type of based host application. Intel will still be here, and ARM will continue to grow because of this huge wins on the mobile market. So this is going to be evolved, and the big player, Cadence and Synoptics and others, will continue to win. This is from the hardware side. On the software side, I have the feeling that the answer will be no, because there are so many innovative coming from universities. All of this platform came from universities in UK, in US, and you never know what will come soon. Okay, new type of framework, new type of platforms, and Nvidia will still want to be. So the Nvidia is now the Apple. So they have their CUDA, and it's my way or the highway, and you have all others. And Linux is still the ground, source of everything, and everything will be on top. I don't see Windows is winning in this type of market, and it's only me. But I don't see any type of standardization in this type of market, because you have a room with 10 people, you will have 20 ideas and 30 different thoughts and 40 different of arguments going different direction. This is me only with my experience. I can say I hope that I'm wrong, but in the past experience, no, it's still going to be complex. I see a level of tools that try to make it more and more easier in a matter that will be shorter of time. Again, 5-7 years ago, to go from nothing to a real AGI vision application, you need to have 2 to 3 years until you start in production. This will be shortened to a 1 year time frame, and this is what I'm feeling about that.
Yeah. Okay. All right. Well, look, fantastic. I mean, we're kind of more or less running out of time. I just wanted to ask one last question to you, which really follows on from what you were just saying. You've had this experience of you worked for a period with Edge Impulse. Edge Impulse then was acquired by a semiconductor company, by Qualcomm. So do you think it's likely that we're going to see, you've been talking about these like mushrooms, you said these software companies springing up to provide sort of parts of the AI solution. Do you foresee that then each of the semiconductor companies, so you're deeply involved with DeepX, but likewise ST Microelectronics, NXP, and so on. Do you think that each of them, like Qualcomm, has brought Edge Impulse inside and made it a Qualcomm company? Do you see that each of them is eventually going to have to kind of pick a software company and acquire it and bring it inside, and so essentially develop their own solution for themselves that way?
Yes. So this is a big yes. And again, let's look at in the last 5 years. Okay, ST Micro acquired a company called Cartesium that helped them to build this type of cube AI type of development. Infineon acquired a company called Imagimob that helped them, with the AI modeling to support their PSOC edge. Renesas acquired a company called Reality AI to support predictive maintenance microcontroller type of market. Qualcomm acquired Edge Impulse to support their AI story with the Dragon Wing. Now, this is one layer, because what I have learned in working with semiconductor industry in the past 25 years, semiconductor companies know to do semiconductors. They are not software companies, okay? And all the time they acquired talented people needed to acquire a needed market, or to solve a problem that they were not able to do it internally. These are the two types of acquisition you see in the market, and I believe that it will continue. And by the way, it's not all around AGI simplification, because there are more issues and problems that are coming. For example, you already implemented AGI into your application. Excellent. You want to get a better accuracy on your models. So then you need to have an OTA capability that everything will be secure. So secure boot, secure OTA. So then you
OTA, so over the air updating.
Exactly, over the air update. So then you can pause your development, your status a project, and then gather more data, send it back to the cloud, all securely, retrain your model, reprogram your solution so it can run again in better accuracy. And then Qualcomm acquired a company called Founders AI that support this. And I see many companies are now going into this market. And again, the semiconductor industry is huge. These guys are making a lot of money. They will need to buy companies that can solve a problem. And I will see more and more on that. And by the way, it's an opportunity for the young engineers, create startup all around the world, solve problems for big companies that maybe they can be acquired or maybe they can be partners and continue make profit as a partnership with them. So I see a huge opportunity there. And this is where I see the market is going. Okay, because more problems, more technology, more innovating, more complexity, more problem solving, and this will go over and over and over.
Mm-hmm. Fantastic. Well, look, thank you, Amir. We've had a really sort of fascinating run through all sorts of aspects of edge AI and how it affects the semiconductor market that we're both involved in. It's been really, really interesting. Thank you so much, Amir Sherman, Global Business Development Consultant, for joining me on the SemiConscious Podcast.
Thank you very much. Thank you much. It was wonderful. It was awesome.
Thanks for listening to this latest episode of the SemiConscious Podcast. You can subscribe on your normal podcast listening channel or watch out for our next episodes coming up. We'll have plenty coming. Hope you enjoyed it. Bye for now.